Hey everybody, I'm Andrew from Lampro Event Solutions. Welcome to our fourth online sound training session that'll be looking at the different kinds of processors, mainly focusing on digital mixing consoles, since the different kinds of processors are already built into them. Please remember to follow us on Facebook and to subscribe to our YouTube channel to receive updates for all the future sessions that'll be coming up. If you're already subscribed, make sure to hit that notification bell to stay updated about our latest videos. Just a quick mention regarding my company. Lampro Event Solutions specializes in technical services for the events industry, and we're a supplier and installer of professional sound, lighting, AV and staging equipment. If you need any of these services, including live streaming or video recording and editing, please send me a message or visit our website at www.lamproaudio.co.za. As was mentioned in the previous sessions, we make use of the following professional brands, namely TurboSound, Behringer and Wharfdale speakers, as well as Shure, Sennheiser, Audix and Samson microphones, and Allen & Heath's range of analog and digital mixing consoles. Other processors include Radial Engineering and DBX. The following page includes all the references that are used for the training sessions, including the Yamaha Sound Reinforcement Handbook, as well as a few others which can be downloaded from the link in the video description below. In session 3, we had a look at the main processor in the sound system, or sound chain, namely the mixing console. We also discussed the layout of the sound chain and the different kinds of processing that takes place, and had a look at the practical features of the analog mixing console. In this session, we'll briefly cover the remaining types of processors, as well as other digital mixing console examples, before diving into a practical session with the Allen & Heath SQ6 digital mixing console. If you missed the intro in the previous session, here's what you'll be looking at. Right, let's quickly have a look at the different kinds of processors so we can get into the practical side of processing with the SQ6. As was mentioned in the previous session, signal processors in sound systems are devices that change the characteristics of an electric audio signal in the following ways: preamplification, input sensitivity attenuation, equalization, audio level attenuation, compression, and amplification. We will have a look at the remaining types of processors, namely DI boxes, dynamics processors or compressors, limiters and gates, as well as graphic equalizers and effects processors. DI boxes or direct injection boxes are used to convert unbalanced audio signals into balanced audio signals. They are commonly used with instruments such as acoustic guitars, bass guitars, keyboards or any other playback device that produces unbalanced audio signals. DI boxes are used when unbalanced audio signals need to cover a distance that is longer than 10 meters that will prevent interference and electrical noise from affecting the audio signal. DI boxes usually have unbalanced TS or RCA inputs with a balanced XLR output on the other side. Most guitar pickups have low output levels, and active DI boxes are usually the best option for them, since the outgoing audio signal is boosted by a phantom-powered buffering circuit. The input level can be attenuated via a -15 dB pad switch if needed. Keyboards and other playback devices, for example laptops and DJ mixers, have high output levels, which passive DI boxes are well suited for. Below are examples of an active DI box on the left and a passive stereo DI box on the right. As the name suggests, dynamic processors are used to adjust the dynamic properties of an audio signal. Compressors are used to compress or even out fluctuations in audio signals. Compressors are very useful for vocals and can be inserted on individual channels, groups, or mix outputs. Audio signals are adjusted via the input, threshold, ratio, attack, release, and output rotating faders. The input rotating fader attenuates the level of the incoming audio signal, and the threshold rotating fader selects the dB level where compression will start. The ratio rotary fader will select the amount of compression that needs to be applied. The attack rotary fader adjusts how fast or slow the compression is applied. The release rotary fader selects how fast or slow the compression will be released from the audio signal. The output rotary fader adjusts the output level of the audio signal. Limiters are very similar to compressors, but instead of compressing audio signals, limiters will limit audio signals from passing a selected threshold. Limiters have input, threshold, and output rotary faders. The threshold rotary fader selects the dB level that the audio signal will be limited to and will keep the outgoing audio signal constant at the selected audio level. The input and output rotary faders work the same way as the compression rotary faders. Below is the example of a stereo dynamics processor, the DBX1066, with dual compressors, limiters, and gates. Gates have a different function altogether. They prevent incoming audio signals from being passed through to the outputs, unless the audio signal goes beyond the selected threshold. Audio signals are adjusted via the input, threshold, ratio, and output rotating faders. All the functions are similar to a compressor, but the threshold will determine when the gate will be opened for the audio signal to pass through to the output. Gates are also very useful for vocals and drums or any type of microphone application to cut out unwanted ambient noise that might be produced by open microphones that are not being used. The image below is an example of a quad-gate compressor, namely the DBX1074. Graphic equalizers are known as parametric EQs, since they make use of linear faders to adjust certain preset frequencies. When the linear faders rest in the middle, there is no adjustment taking place on any of the available frequencies. Once the linear fader is pushed upwards, the designated frequency will be boosted. Pushing it downwards will cut the frequency. The amount by which the frequency can be attenuated usually ranges from -15 dB to 0 dB and from 0 dB to +15 dB. There are three types of graphic EQs, called first, second, and third octave graphic equalizers. The first octave graphic EQ includes 3 to 10 frequency bands that can be attenuated. The second octave graphic EQ includes 10 to 15 frequency bands, and the third octave graphic EQ includes 15 to 30 frequency bands. Graphic EQs are usually inserted on a mixing console's outputs that are used for FOH or front of house and monitor speakers to eliminate any problem frequencies that may cause feedback or unclear sound that is caused by the acoustics of the venue or the frequency response of the main speaker system or stage monitor speakers. Below is an example of a third octave graphic EQ, the DBX IEQ31. Effects processors have very basic functions and is not an important or vital link within a sound system. They are very useful for music productions where vocals, drums, and certain instruments are present. Effects processors enhances or changes the characteristics of certain sounds by making use of the following effect categories: reverb, delay, chorus, flange, pitch shift, phase, and many more. There are several effects that can be chosen from each of these effect categories. Common reverb effects are known as hall, plate, chamber, and room reverbs. The same goes for all the other types of effects. Different parameters of each effect can also be adjusted, for example time, shape, delay and offset to get the ideal sounding effect that is needed. FX processors usually receive audio signals from the mixer's post-fade aux, and the processed audio signal is sent back to the mixer's aux return or one of the input channels. Below is an example of a stereo effects processor, namely the Lexicon MX400XL. Here are some examples of digital mixing consoles. All of them have built-in dynamics, graphics, and effects processors. First, we have the Yamaha O1V96, one of the earliest digital mixing consoles that were launched in the early 2000s. Next, we have the Allen & Heath QU16, an affordable digital mixing console with 16 local inputs and a range of processing features. Here, we have the Soundcraft SI Expression 3 with 32 local inputs. The next one is the Digico SD12. That's a top-of-the-range mixing console with various features and multiple inputs, outputs, and processing possibilities. The next one is the Allen & Heath SQ6 that we'll be having a look at next. Right, that covers the other types of processors that's still related to the mixing console section. We'll have a look at crossovers and amplifiers in the next session, since they are closely related to loudspeakers, especially when it comes to active speakers. So let's have a look at the Allen & Heath SQ6 and how the different types of processors can be used on a digital mixing console. In the previous session, I demonstrated how the inputs, gain, EQ, auxes, and outputs on an analog mixing console work, and the same principles will be applicable to the SQ6. We'll do a quick run-through of the overall features of the SQ6, followed by a closer look at the processing section, as well as other features. First, we'll have a look at the overall layout of the SQ6, followed by a closer look at the processing section. As you can see, there's 25 motorized faders at the bottom that can be used to adjust audio levels for input channels and output masters, such as the main left-right, groups and matrices, as well as the aux, sends, and returns. The faders can be assigned to any of these functions on any of the 6 fader layers. At the moment, I have the local input channels assigned to layer A, and some of the stereo channels, aux sends, effect sends, and group and DCA masters are assigned to other layers. These can be configured in any way that is suitable to your liking. If we quickly go to layer B, you'll see there that we've got the remaining input channels on the left there. On the right here, I've got the stereo channels assigned. There's some of the groups assigned over here. If we go to layer C, you'll see all the aux sends and returns on the left there, the DCAs and matrices on the right, and on layer D, I've got some of the other DCAs assigned over there. So the fader layers can be assigned in any way that suits your liking to get the desired workflow that you prefer. As you can see on the picture, the back panel features 25 local inputs, one of which is assigned to the talkback mic, and 14 mix outputs that can be assigned to any of the mix or aux and group outputs. Mix outputs 11 and 12 are assigned to the main left and right masters by default, but this can be changed if needed. The 12 mix outputs, or auxes, can be selected on the bottom right of the console. The back panel also features 2 stereo inputs on the left that can be used for playback devices, for example laptops and media players. The AES output can be used to send a digital audio signal to a relevant AES device. The alternative A and B outputs can be used as an additional output that can be linked to any of the mix outputs. The I/O port, which features a Dante expansion card at the moment, can be used with a range of different expansion cards, including the SQ Dante, Waves, and S-Link cards. The S-Link card is used for Allen & Heath's own protocol that is used with their range of digital stage boxes, for example the AR2412 that is being used at the moment. The USB-B port is used to send or receive multitracks for recording or playback purposes, and the network port is commonly used with a router, so the SQ6 can be accessed remotely via a laptop, tablet or smartphone when using the SQ Mixpad and SQ4U apps. The SU-Link port is used to connect to Allen & Heath's range of digital stage boxes, including the different versions of AR, AB, GX, and DX stage boxes. This allows the console to be expanded to a total of 48 input channels and 24 mix outputs. If we go back to the front panel, you'll see that each fader strip section has a chromatic LED, a baffle, select, and mute button on it. The chromatic LED indicates the incoming or outgoing audio level on the fader strip that will change in brightness and color depending on the level of the signal. The baffle is used for the pre- and after-fade listen to monitor the incoming and outgoing audio signals depending on how the fader is being used. The select button will select the designated channel or output to access any processing or features that might be assigned to it. The mute button will mute the input channel or the output that is assigned to it. The LCD scribble strip at the top of the mute button allows the user to name the input or output that is assigned to the fader and can also be changed to different colors for easy identification. These features are applicable to all the different fader strips on the SQ6. If we go to the top section of the console, you will see 6 soft keys in the top left-hand corner over there. There's 2 soft keys just below the GEQ section over here, and another 8 soft keys at the top right section of the console. All 16 of these soft keys can be assigned to a number of uses. They are commonly used for mute groups, which I assign to soft keys 1 to 6. Soft keys 7 and 8 are used for the tap tempo that is part of the delay effects that are assigned to them. Soft keys 9 to 11 are used to arm, start and pause the built-in SQ drive multi-track recorder that can be used with the USB-A port up here or the USB-B port at the back. Soft keys 12 to 16 over here are used to gain access to some of the DCA features. Like I mentioned, all of these soft keys can be assigned to a range of functions in any order that you see fit. The soft rotaries on the left here is quite a nice feature and works on the same principle as the soft keys, but also feature level adjustment. I assign them to the 4effects unit returns for easy access over effects levels that are sent to the different mixers. They have their own mute buttons and scribble strips for easy identification. The soft rotaries can be used for a number of things, including aux, groups and matrix masters, or to adjust levels that are sent to recordings. The options are really endless. On the far right of the console, we have the 4effect sends that are used to send any of the channel's audio signals to one or all of the effects processors, which works in the same way as a post-fade aux. Once you press the buttons, you'll get access to the different effects units and you can send whichever channels you want to those effects. The 12 mix buttons are used as aux sends that can be used in pre- or post-fade mode to send any of the channel's audio signals to the assigned mixed output. That can be used with stage monitors, additional speakers, or recordings. You simply select the desired mix and send the channel's audio levels with the faders to the selected mix outputs. The master fader on the right will act as the aux master. On the left here, you will find a set of copy, paste, and reset buttons. They are used to copy any of the selected channel's parameters and processing settings that can be pasted to another channel to make your workflow a lot faster when needed. So you'll basically hold the copy button in, press the select button to copy a channel's parameters, and then from there go, press the paste button and select the next channel to copy it over. The pre-fade button over here is used to show and assign any of the channels to either pre- or post-fade mode. The channels that are in pre-fade mode will have their select buttons here illuminated. Since we're using the main mix in post-fade mode, the select buttons are not illuminated when holding in the pre-fade button. On a pre-fade aux, they will be illuminated and can be changed to post-fade by holding in the pre-fade button and pressing the select switches. So if we hold in the pre-fade mode, you'll see that on aux 1, all of these channels are in pre-fade mode, and when you select them, they go into post-fade mode. The Assign button will show if a channel is assigned to the selected mix. You can unselect any of the channels by holding the Assign button in and then pressing the Select buttons along with it. So if I press the Assign button now, you will see that all of these channels are being sent to the main mix. And holding in the Assign button and simply pressing the Select buttons, you unselect those channels from the mix. If you wanted to put back the channels into the mix, you simply hold in the Assign button again and press the Select buttons once more to send it back to the mix. The blue Channel to Mix button will show which mix outputs a selected channel is being sent to. At the moment, channel 1 is selected, and when I select the Channel to All Mix button, it will show you which mixes the channel is being sent to. At the moment, the channel is being sent to aux 1 and some of the groups. And if I wanted to send the channel to any of these other mixers, I simply push the faders up, and the selected channel will also be sent to those mixers. The View button is used with the scribble strips to display all the input channel numbers and patching configurations that the channels have been assigned to. If a channel has been given a custom name, the View button will display the input number as well as the patch number that is used from either the local or S-Link inputs. I quickly want to show you how the GEQ feature is used before we look at the processing section of the SQ6. The GEQ button here will access the built-in third octave graphic equalizer. Once we've selected the desired mix, in this case it's the left and right mix, you can go ahead and select the GEQ, and now the faders can be used to adjust the different frequencies that is shown on the different fader strips via the LCD display. When the faders stay in the middle, the frequencies remain flat. When pushed upwards, the frequencies will be boosted, and when they are pushed downwards, the frequencies, will be cut. The chromatic LEDs here will also give you an indication of which frequencies might be peaking, so use them to do the adjustments accordingly. And when you press the Select buttons, it will select the corresponding frequencies on the graphic equalizer to 0 again. The Processing button will show you all the different processes that are being used on a selected channel, including your gain, your high-pass filter, your gate, compressor, and pan functions. Each one of these can be selected independently to change their different settings. The high-pass filter, gate, and compressor functions can be switched on and off via the buttons on the left. The Routing button will show you the various routing options that the channels can be routed to, including your DCAs, your mute groups, your main, mix, and effect sends. And the Meter button will show you the different input and output level meters, as well as the RTA or real-time analyzer that is assigned to the main left and right outputs at the moment. If we have a look at the input meter section, you can see the audio level meter for input 1 over there. When we go to the mix meters, you can see the audio levels on aux 1, the main left and right, and the matrices. And the RTA gives you a clear indication of the different frequencies that are being sent out of the selected output. In this case, it's the main master left and right. That is also linked to the built-in GEQ over here. The Effects button will show you all the different effects engines that can be accessed in the effects library that can be assigned to any of the 4 effects units on the left over here. So if I wanted to change one of the effects units, I simply press on the selected effects units, either 1, 2, 3, or 4. I press the Library button, where I'll get different options for reverbs, delays, modulators, whatever you prefer, and you can select the desired effect with the rotary fader at the bottom here. Let's recall that effect into effects unit number 4, and I'm ready to go. The Scenes button will show you all the different scenes and shows that can be saved to a USB flash drive or the SQ6 internal memory. The setup button will show you the different setup features of the console, and there's a number of functions that can be adjusted. Under audio, you've got your PAFL, TalkBack, Signal Gen, Audio Sync, in-out port and USB functions. Under Surface Preferences, you've got your strip assign, where you can assign your different input channels or inputs to different faders, and the same with the outputs. Your soft controls are used for your soft keys and soft rotaries to assign those to different functions. We won't really have a look at foot switch. Surface Preferences includes settings where you can change the brightness of your touch screen, the scribble strips, or all the LEDs on the console. The mixer configuration has different input, outputs, and bus configuration settings. In your ganging, we'll have a look at later. The network setup is used if you connect the console to a router that's used for wireless access. And you can also set up different parameters for different users on the console. The utility button is used to access all the utilities of the console, and you'll have a number of functions under General, Data, USB Utility, SQ Drive, and Auto Mic Mixer. Under General, you've got your diagnostics of the console, calibration that you can use to calibrate your faders. Under MIDI, there's a MIDI control panel over there. And under add-ons, you can add any of the additional deep processing units that's available for purchase. Under data, you can save shows, scenes, and libraries to a USB flash drive. The USB utility is used to format a USB flash drive to the specific format that's needed for the console, and it's also used for the firmware updates to update the console. Under the SQ drive, you've got your stereo and multi-track media player and the recorder that can also be used, and the Auto Mic Mixer that is used to select specific channels with the Auto Mic mixing feature. The I/O button is used to patch your different inputs and outputs from different locations, whether it be from the local inputs and mixed outputs or tie lines that is used via the USB-A or USB-B port for multi-track recording. If a digital stage box is connected, it will also appear in the S-Link section over there. So on the left, you can have a look there. We've got our inputs that is already assigned to some of the local inputs over there. If you have the S-Link connected, which I do have at the moment, you can patch any of the inputs to the S-Link. And the same goes for your outputs and your tie lines. Since we're dealing with the different types of processors, we'll have a look at the processing features a little closer. As was mentioned, the processing button will show you all the processors that are available for each input or output that will be displayed on the touch screen. I'll select channel 1 that's being used for my microphone, and we'll have a look at all the processing that's available on the processing screen. The gain is used to adjust the input gain of the incoming audio signal with a 48-volt phantom power switch below it that you will need to switch on for any condenser mics or active DI boxes. As always, make sure to have your gain set up properly and leave yourself sufficient headroom to avoid distortion. The high-pass filter is a sweepable high-pass filter that can be switched on with a switch on the left, and the frequency can be changed with a rotary fader next to it. The display will also show how the high-pass filter is being applied to the audio signal, and at the moment I've got a high-pass filter of 107 Hz selected on the input channel. The gate can be switched on with a button on the left, and the threshold can be set with a rotary fader next to it. Other parameters can be adjusted on the touchscreen when the gate has been selected. And if we have a look there, you'll see your attack, hold, and release parameters. And these can be adjusted by simply selecting it and using the encoder at the bottom here to make the needed adjustments. The compressor works in the same way as the gate with the relevant switch and threshold rotary fader. The different parameters can also be selected and adjusted on the touchscreen when we go into the compressor section. And you'll see here that you've got parameters for the attack, release, the compressor ratio, the threshold, and the gain that can all be selected and adjusted with the encoder at the bottom here. So if I didn't want to use the threshold rotary fader over here, I can do it with this encoder by selecting threshold over there. You can change the ratio of the compression by selecting that window. And the attack and release times can be changed over there. The pan rotary fader will send the channel's audio signal to both left and right outputs when it remains in the center, or it can be panned to either sides to send the audio signal to the corresponding outputs. So at the moment it's in the center, sending it to both outputs, panning it left, panning it right, and back in the center again. If we go to the parametric EQ section, you will see that we have 4 sweepable parametric EQs, namely the low frequency, low mid, and high frequency EQs. When any of the 4 frequencies or EQs are selected, the width of the frequency itself, and the gain of the frequency can be adjusted. The in button needs to be switched on to activate the EQ on the selected channel. A recent firmware update enabled the SQ6 to show an RTA on each input channel's EQ, a very useful tool to pinpoint problem frequencies. The display itself will give you a clear indication of all the different frequencies that might be selected, depending on which frequency is selected, and the gain adjustments that are also done to the selected frequencies. The RTA will also display and show you where any problem frequencies might occur, and the graph there will show you the actual adjustments that's been made to each one of the frequencies. The talk button switches the talkback mic on and off that's been connected to the talkback mic input. By default, the VU meter will show the audio level that is sent out of the main outputs when the baffle feature has not been selected on any of the channels or outputs. Okay, so that's it for the 4th session of the online sound training course that covered the various types of processors that are featured with digital mixing consoles. In the next session, we'll have a look at crossovers, amplifiers, and loudspeakers. If you enjoyed this session with the SQ6 and would like to learn more about the other features, please let me know and I'll see what we can do to cover the SQ6 in more detail. Please remember to like and to follow us on Facebook, Instagram, and Twitter, and to subscribe to our YouTube channel for upcoming sessions and reviews. As always, if you have any questions or comments, please leave it down below. Thanks guys, I'll see you with the next one.